All right, good morning, everybody. So today I wanted to talk about probability, and I'm going to be pretty specific about the concepts we're going to talk about. I'm going to go over the basic definition of probability. I'm going to talk about, especially within the basic definition, how do you count the number of desired objects? So there's a couple of ways we'll address with that. I'm also going to talk about the binomial theorem. You've seen that. That was when we did Pascal's triangle. We're going to talk about tree diagrams and a probability distribution table. So that's where our big ideas are going to be compacted into this one worksheet. And if you want to go ahead and print that out, we're going to go ahead and do this. And I'm going to jump around a little bit. So the first and the last problems are very similar to each other. But big reason about probability, it's one of my favorite subjects in terms of where it also leads. So probability goes into a lot of different directions. But one of the areas that I'm interested in is statistics, just because sometimes I hear stuff on the news and they say these things and I'm thinking, well, is that unlikely, or is that just, could that just happen out of chance? Right. And of course, anything can happen out of chance. But if something's so rare, then you start to question, well, are they lying? Is there a scam going on? That's my head wondering about different things. So let's say, for example, I'll bring it to something you might be interested in. Let's say we're going to play this game. And in this game, I have a bunch of markers. In fact, I have a bin of like 20 markers here. And random colors. This is my bin of extra markers that I find along the way. All right, but here's the game. I'm going to reach in there. I'm going to grab 4 of them. If the 4 markers are all black, then you have double the homework. Now, granted, most of the markers are not black. I only have like 6 black markers in here. All right. But if they're not all black, then we just do regular homework. Or in fact, I'll give you 80% of the homework. All right. So a little bit less. I'll make the problems a little bit less. So let's say I do this and I shake it up. Right. And I reach in there and all of a sudden, bam, I grab out 4 black markers and say, bam, you have double the homework. All right. And you're like, oh, man, that sucks, right? Because that's not very likely going to happen. All right. We do it again. I mix it up. I reach in there. Bam, it happens again. You have double the homework. At this point, you might be thinking, something weird is going on. Well, that gut feeling of something weird is going on is that idea of, hey, the chances of that happening are so rare that Ms. Sato probably is cheating, or something weird's happening with that markers. But each time I'm shaking it. All right, let's say I do it again and then bam, oh, they're all mixed. She does have 2 black markers. You should be questioning that as well. All right, so I do it again and all of a sudden, bam, I'm going to cheat this one. Mix it up, bam, 4 black markers again. See? So that intuition that you have is based off your internal belief about probability, right? You think, oh, that's really weird that's happening. How rare is that? Or is that, within reason? Okay, so that's what we're going to talk about. We have to be able to find a probability to make that jump of, hey, that's so weird, I think you're cheating. All right? All right, so let's talk a little bit about how to calculate those and we will calculate the probability of me grabbing 4 black markers out of a stack of 20. All right. So you can title your paper Probability. All right, so the basic definition of probability is the probability of an event happening, like picking 4 black markers, is the number of desired. That'll be 4 out of I think there were 6 black markers in there, out of the number of possible markers. Now, the way I chose a group of 4, so that math is a little bit more complicated than doing something like this, right? If I want to know the probability of choosing a black marker is 1 out of 5. The one I want out of the total. The probability of me choosing a brown marker is 2 out of 5. That's an easy counting to do, right? But the counting that we did in this game is a little bit more complicated. And that's what I want us to jump to. But before we do that, right, it's the number of black markers, and it's not just black markers, it's a group of 4 out of 6, right? I'm choosing a group of 4 out of 6 out of the number of groups of 4 out of 20 markers. So these are a little bit more difficult to count. So what I want us to talk about is how do we count? 1, 2, 3, 4, 5. Other keywords are like arrange. You'll see that word happening when they want you to just give me a count of something. So take, for example, I want to count the number of ways to arrange, I used both of the words, arrange 3 objects. So we'll do it a little simple. So if I have 3 objects, I can count it. This is 1 way. I could switch to that. That's 2 ways. I could put the blue one first, 3 ways, 4 ways, 5 ways, 6 ways. Okay, yeah, we don't want to sit there and arrange things all the time. So the shortcut in looking at that is I have 3 objects that go into 3 spots. The first spot can be occupied by 3 different pens, right? Once a pen is chosen, now I'm left with 2 pens, and the last spot can be occupied by 1 pen. This is called the fundamental counting principle, 3 times 2 times 1. So there are 6 ways to arrange 3 objects. Cool? So let's do a problem here. This is the first one on the worksheet. So how many ways can we line up 4 people? All right, how many spaces are we going to have? 4. 1, 2, 3, 4, because that's what I'm interested in. Okay, so now there's some conditions here. It says Joyce has to be first. There are 9 people. Joyce has to be first. There's only 1 Joyce. In the second space in line, how many people can I choose from? I can choose from 8 people because Joyce was already taken out. Then there's now 7 people left, 6 people left. So I have a total of 336 people, or ways, not people, ways of arranging 4 people. Number 2 is done the same way. I have a 3-digit number, 1, 2, 3. I'm going to figure out what can go in each spot. The first digit says it has to be at least 800. So I can have an 8 or a 9 go in that spot. So I have 2 choices to go in that spot. Then it says there can't be a 2 or a 5. So really, I don't have 10 digits. I don't have 0 through 9. I have 8 digits to choose from, right? But I've already taken a digit for the first one, so I really only have 7 digits to choose from. And then if I take another one, now I have 6 digits. Again, I typically have 10 digits. They said the first digit has to be an 8 or a 9. So that got taken away. Then they told me a 2 and a 5 can't be in there. So 2 of my choices got taken away. So I have 7 choices for my second spot. There's my 7. And then I take away a number. Now I'm left with 6. Right? And that's a total of 84. All right. Now, our problem was not as simple as just counting that like that. Our issue was that I took a group of items. Right? And you've seen this when you, out of a group of 20 markers, how do you select 4 of them? So that's where this button, the C, right, NCR. So out of 20 items, I want to choose 4. So there were 20 markers, and we wanted to choose 4. We can just write it 20, choose 4. And that's a button on my calculator. So we go 20, go to math, arrow over to probability, and it's the third one down. 20, choose 4. There's 4,845 different groups of 4 that I could have grabbed out of that bin. Right, so these are all the possible combinations of 4 markers that I have. So in fact, that's my denominator up here. And then if I wanted the numerator, how many black markers could I choose? How many ways could I get just black markers? I had 6 black markers and I wanted 4, so that's going to be 6, choose 4. So 6, choose 4. That's going to be 15. And there's a formula for this. I'm not too worried that you know the formula because you're going to have access to technology. Also, you could put it in the Google bar. You could just type in the Google bar 20, choose 4, and it should give you that number as well. All right, so if I wanted to find the probability of me selecting 4 black markers out of 20 markers, that's just going to be 15 over 4845, right? What I want, black markers, the ways I can select a group of 4. And if I put that as a decimal, really you want to leave it as a fraction whenever you give an answer, because this tells me information. This also, the chance of that happening is 0.003. That is extremely rare. So if I picked out 4 black markers from there, especially if I did it twice in a row, you should be questioning whether these are trick markers, whether I'm cheating, whether something is going on. So that's where probability in real life comes into play. The chances of that happening are so rare that something weird is happening. All right. All right, so let's go ahead and take a look at 2 of the problems that show up on your worksheet. Number 7. So a team of 5 students is to be chosen at random. So there's what I want, a team of 5 students to take part in a debate. The team is to be chosen from a group of 8 medical and 3 law students. All right, so how many students are there? 11. All right, so there's a total of 11. So like my case, 11 markers, and I want to choose a group of 5. In fact, now we know what the denominator is going to be, right? So the probability of getting only medical, so that means 5 medical. We already know there are 11 students and we want to choose 5. Now, how many ways can I select 5 medical students? Well, there are 8 of them and I want to select all 5. And that comes out to be 56 over 462. All right. Next one, all 3 are law students. So the probability of 3 law, but I need to select 5 people. So it's 3 law and 2 medical. Right, so the denominator still stays the same. 11 choose 5. I'm still selecting 5 people, but I want 3 law students. So that's going to be 3 choose 3. All right, 3 law students. I want all 3 of them, but I still need 2 more people. So out of the 8 medical students, I need to select 2 of them. All right, so that's going to be 28 over 462. And the reason why it's multiplication is because these events are independent and I'm allowed to multiply them together. All right, so that kind of takes care of the idea of some basic probability concepts. Right, now there's other things that are involved with probability, like the way I phrase the question of getting, let's say, exactly something. So this is our binomial situations. Let's write that down. You know it's going to be, there's other requirements for it being binomial, but this is the key word that you're going to notice, is how many ways can I select exactly 4 of something. All right. All right. So the binomial formula is n choose r, the probability that I want it to happen raised to the r, times the probability of 1 minus it happening to the n minus r. This is the total. This is the desired. This is the probability of the desired. 1 minus the probability of something is going to be the probability that it's not that, right? And then n and r you already know, right? That's what we want. So the best way to look at this one is look at it through an example. Right, and this is the example we'll do, number 3. So the probability that a basketball player will make a given free throw is 7 out of 10. Find the probability that the player makes exactly 8 out of her next 10 free throws. So this is the total. This is what we want. And this is the probability. You have all the parts. So going back to our formula, 10, choose 8. And then the probability that they make it is 7 out of 10. Right? There's 8 times she's going to make that, which means she's going to miss it twice, right? How many times is she going to, what's the probability she misses? 3 out of 10, right? Because if she makes 7 out of 10, she's going to miss 3 out of 10. And again, you can put this directly into your calculator, and you should get approximately 0.23. So she has a probability of getting exactly 8 out of her next 10 free throws is 0.2335. All right, we could do this again here. Let's do it again with the calculator. So factory makes calculators over a long period. 3% are found to be faulty. Okay, so there's your probability, 0.03. We convert it to a decimal. There's 50 calculators, and these are the number of faulty ones. So find the probability that 3 are faulty. So again, we're just going to plug it in. 50, choose 3. The probability that they're bad is 0.03, and I want 3 bad ones. The probability that they're good is 0.97, and I want 47 bad ones. And really, this is connected to a tree diagram, and I'll show you that in our example with the tree diagram. Right, and this is going to come out to be some number, and I think IB allows you to just leave it like that. I don't think you have to put it into a decimal. I'm going to leave it like that for now. All right, find the probability that 1 or more are faulty. So the probability that 1 or more are faulty means the probability of exactly 1, exactly 2, exactly 3, all the way up to all of them being faulty, so exactly 50, right? And I'd have to figure out each one of these separately. That sounds like a bad idea. But they're also, to get the total options, the probability that none of them are faulty, if I just take 1 minus the probability of none, that will give me this right here. So think about that for a second. 1 minus the probability of none will give me the probability of exactly 1 plus exactly 2 plus exactly 3. And I probably should put like the probability sign here. I'm not adding numbers together. All right. So the probability of none, 1 minus that will give me the rest of it. So it's going to be 1 minus the probability of 50, choose 0, 0.03, raised to the 0, because I don't want any of them to be faulty, 0.97 to the 50th power. All right. That's a really common one. Is at least 1 is the same as 1 minus the probability of none. All right. All right. The next thing I want to talk about is, well, let's do number 5. Number 5, actually, I probably should have done with the counting problems. How many different ways can you arrange the letter bookkeeper? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 letters in bookkeeper. Okay. Yep. So that's going to be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. I don't know if you knew this. That's 10 factorial. That just means I start at 10 and I multiply my way all the way down to 1. The thing is, there's some repeated letters. So if you want them distinguishable, you have to divide out the repeats. So the letter O repeats twice. So I'm going to divide by 2 times 1. The letter K repeats twice. So that's going to be 2 times 1 again. And the letter E repeats 3 times. So that's 3 times 2 times 1. So I'm dividing out the repeats of the letters. This is the letter O, this is the letter K, and this is the letter E. And you might see it like this: 2 factorial, 2 factorial, 3 factorial. All right. Last one we'll take a look at is the tree diagram. So here we go. So we want to draw a tree diagram with 3 red candies, 4 green candies, and we want to draw 2 without replacement. All right. So we're going to pick out what's going to happen first. I'm going to pick out a candy, right? It's going to be either red or green. And then I'm going to draw another one. I could either get a red or a green. And then I could go green, red, or green, green. The probability that I get a red is 3 out of 7. The probability I get a green is 4 out of 7. So what I'm doing here is I'm listing out the possibilities. This is my first draw. This is my second draw, right? I'm drawing 2 of them. So I always put down the item I'm interested in at the edge of the tree. On the branches here, I put down the probabilities. Now, since I did it without replacement, if I draw a red first, there's now going to only be 2 red candies left. So it's going to be 2 out of 6 because I've taken away one of the candies. And this will still be 4 out of 6 because there's still 4 remaining. Right, this will be 3 out of 6 because there's still 3. I took out a green. And this one will be 3 out of 6 because I took out a green here, right? Now to find the probability that I get a red, red, the probability of getting a red, red, I multiply the branches. So red is 3/7 times 2, 6, which comes out to be 6 over 42. I'm going to do the same thing. I'm going to multiply for green, green. I multiply this pathway. That's going to be 12 out of 42. Green, red is going to be 4 times 3 is 12 out of 42. And this one's also going to be 12 out of 42. All right. All right. And then finally, to make a probability distribution table, all we're doing is we're organizing this information in a table. And we're going to do it specific to the number of green candies chosen. So X is our number of green candies chosen. So the way you make your table is like this. I could select no green candies. That's this choice right here, right? So the probability of that happening is 6 out of 42. I could select just 1 green candy. This is red, green, sorry. That's these 2 choices, right? This is the pathway for just 1 green candy. So how many ways can that happen? 12 plus 12 is 24 out of 42, right? There's 24 ways out of 42. And then finally, I can select 2 green candies. That's going to be 12 out of 42. So whenever you see make a probability distribution table, they're just taking the information from a tree diagram and laying it all out. All right. So those are the big ideas. I'm going to jot down a few of them just in words. So for a tree diagram, you could do this with or without replacement. It doesn't matter. It's just going to change the probabilities on the branches. So that's what I want you to remember. Probabilities go on branches. And then I'll call them the leaves, right? That's the endpoints here. These are branches, and I don't know, I just made that up. Those are the leaves. That's where the outcomes go. Like if you're talking about pennies, then you know, like the flipping of a coin, you put heads or tails. All right, a probability distribution table. What it does is it describes all possible outcomes with the probabilities. All right, so X describes all possible outcomes. So 0, 1, 2, that's what we had in our situation, right? And then the probability of getting 0 heads or 0 green, 1 green, 2 green. All right, and sometimes they refer to this as the random variable. That's a variable that we're interested in counting. All right. All right, so I know that was quite a bit. We did go over this, and we will talk about it again on Tuesday. I'll see you guys on Tuesday. Or actually, I'll see you guys on Wednesday because we have Monday off. All right, hopefully you're okay with that. Keep plowing through that D-Days, all right? And we'll make sure we spend time going over those. All right, have a good weekend, 3-day weekend. Woo-hoo.